Hey guys, Mr. King here. Today we're going to talk about compounds and mixtures. We have been talking about atoms and elements, and today we're going to talk about what happens when atoms come together. They're not always by themselves. They are the smallest particles that we have that make up matter, and then we talked about how we've got the smaller subatomic particles within them, but they also join up with one another and they form different things. So that's what we're going to talk about today, what happens when they combine. So first off, we've got a substance. A substance is matter that has the same composition and properties throughout. So no matter what part of it you took, it would be made of the exact same amount of atoms. Example is a bar of gold. It's made of just gold atoms. A sheet of aluminum is made of just aluminum atoms. So it doesn't matter which part of it you take, it's all made of the exact same things. Okay, that's what a substance is. So a substance is pure. It's made of entirely the same atoms. A compound is a little bit different. A compound is a substance whose smallest unit is made up of atoms of more than one element. So if you got down to the smallest particle of a compound, it would be more than one atom. If you look at the picture here, we have H2O, which you guys know is water. That's 2 parts hydrogen and 1 part oxygen. You cannot separate those and still have water. Now, water is going to be our easiest compound to remember because you've got 2 different elements that are joined together to make a new thing. So if you get a really, really tiny drop of water, there is no way that you can separate it further than 2 parts hydrogen, 1 part oxygen. That's what our chemical formula tells us. It tells us which elements make up a compound. So in the case of H2O, H stands for hydrogen and O stands for oxygen. So we know water is made of hydrogen and oxygen, but it also tells us how many atoms of each is in the compound. So there are 2 atoms of hydrogen. That's what the little 2 following the H tells us. Now since there is no number following the O, that means there's just 1 atom of oxygen in the compound water. So the subscript tells you how many atoms of the preceding element are in the compound. No subscript is needed when there's only 1 atom of the element present. So in the case of H2O, there is no subscript needed after the O because there's only 1 atom of that present. We don't write H2O1. You just leave it blank and that lets you know there is only 1 atom in the compound. So the compounds are all pretty easy to read. Like I said, the subscript tells you how many atoms are in there. No subscript is used when only 1 atom of the element is present. I'm going to show you guys a couple different examples here of some real common compounds. For example, NaCl. That is the formula for salt. Okay, this is sodium chloride, and we know it as salt. Salt, you can see after Na, that's the symbol for sodium, there is no subscript. So that means there is only 1 atom of sodium, and after Cl, for chloride, there is only 1 atom of chloride as well, and so that is going to not have a subscript. Now, another really common compound that you guys would know is sugar. Okay, sugar looks like this. Sugar is a bit bigger. Sugar is 12 parts carbon, 22 parts hydrogen, and 11 parts oxygen. Okay, so you can see the subscripts in here tell us some different things. Our subscript right here tells us there are 12 parts carbon, there are 22 parts hydrogen, and there are 11 parts oxygen. Okay, so once again, if it follows right after the atom name, that tells you how many atoms are in the compound. So when you compare salt and sugar, although they look very similar, if you held a piece of salt in your hand and a piece of sugar in your hand, they would look very similar. They are made of a very, very different amount of atoms. You can see if we add these together, we end up with 45 atoms of carbon, hydrogen, and oxygen, as opposed to salt is just made of 2 atoms, 1 atom of sodium and 1 atom of chlorine. So pretty different depending on which type of compounds that we are talking about. All right, so that gives you a little bit better idea about how those elements are designated in the formula. So far we've talked about a substance, and then we've talked about a compound, and now we're going to talk about a mixture. A mixture is a little bit different because mixtures can have different amounts of substances in them. So a mixture is when two or more substances come together but don't combine to make a new substance. In other words, they don't join each other. They're not chemically bonded. Unlike compounds, the proportion of the substances in a mixture can be changed without changing the identity of the mixture. And if you look back here, in a compound, the same elements are always in proportion in a compound. When you have a drink of water, it's always 2 parts hydrogen and 1 part oxygen. It's not like you take a drink and you're like, oh man, that tasted really hydrogen-y. It doesn't happen like that. It's all the same entirely throughout. That's how water works. A mixture is different. Okay, a real easy example of a mixture is chocolate milk made with Hershey syrup. So you take your milk, you pour in the Hershey syrup, squeeze it in, you stir it up, and you take some drinks of it. And when you get towards the bottom of it, you notice there's some of the syrup sitting at the bottom. And your last drinks of chocolate milk are extra chocolatey. Now that's what a mixture is. It's where it can be in different parts, but it's still called the same thing. I used to be a waiter at Lone Star Steakhouse up in Mount Pleasant when I went to college at Central Michigan. And little kids would always come in and say, can I get chocolate milk? So I'd go in the back and I'd get milk and then I'd put syrup in it and stir it up and I'd take it out to them. And sometimes they'd say, can you put more Hershey syrup in it? It's not chocolatey enough. And other times they'd say, oh, it's too chocolatey. And that's what makes it a mixture, is because it was chocolate milk in both cases, but sometimes it had more chocolate syrup in it and other times it had less. Now it doesn't bond to it, so it can be different like that. Some other examples are sand and water. You can pour a little cup of sand into a big bucket of water and it's sand and water, or you can fill an entire bucket up with sand and pour in some water and it's still sand and water. You just have different amounts. Air is another example of a great mixture, because depending on where you're at, if you live in a big city where there's a lot of pollution, the air is very different than the air maybe in like Stevensville or in Baroda, because we have a lot of open air and not a lot of pollution because we don't have a lot of big factories. Our air contains very little pollution. But if you go to a big city, if you go to Gary, Indiana, if you guys have ever driven down to Chicago, you might have smelled Gary, Indiana on the way down. They have a lot of factories, and therefore they produce a lot of air pollution. And that really affects the amount of elements that are in the air. So they have a very different mix of elements in their air compared to us. And then blood is another one. Depending on whether you are sick or healthy, your blood can have different things in it. You can, if you're getting sick, you might have more white blood cells in it. So your mixtures can always change, but it's still called blood, it's still called air, it's still called chocolate milk, it's still sand and water. It's just in different proportions. And the last part about a mixture is you can separate them pretty easily. If you let chocolate milk sit, you will see all of that syrup will sink to the bottom. If you don't stir it up, it goes kind of bad. And so you can break down mixtures into its separate parts. That's what makes it different from a compound. In a compound, you can't separate out. Like in water, you can't separate the hydrogen and the oxygen away from each other. It would no longer be water. In this case, we can separate it out. We can separate those things away from each other and get back to what we started with almost. All right, so some examples of mixtures. A mixture that looks exactly the same throughout is called a homogeneous mixture. And air, blood, and milk are examples of homogeneous mixtures because when you look at the air, you don't really see the oxygen and the carbon dioxide and the nitrogen. You don't see those different atoms in the air. It just looks like it's one continuous substance. That's the same way with blood. When if you've ever cut yourself, it just looks red. You can't see the platelets and the blood cells and things like that. And then also milk. Even though milk's made of a variety of different things, it looks the same throughout. And that's what a homogeneous mixture is. Now the opposite of that is a heterogeneous mixture. And our heterogeneous mixture is where you can see different parts in the mixture. You can see in these two diagrams you got a bowl of candy. You could pick out the gumdrops. If that's all you liked out of those, you could pick each one of those out. Pizza is another great example of a heterogeneous mixture. Let's say you didn't like the black olives on that pizza I have a picture of. You could pick those black olives off, and then you could have the pizza the way you want. So there's a pretty big difference between a homogeneous mixture and a heterogeneous. Homogeneous looks the same all the way throughout. You can't even see the individual parts. Okay, it's almost one continuous unit. Heterogeneous, you can see all the different parts. Like a salad is another heterogeneous mixture. If you don't like tomatoes and you go to a restaurant and they give you tomatoes, you can pick them off. If you have a homogeneous mixture, that would not be able to be done because it's the same all the way throughout. So heterogeneous mixtures allow you to see those different parts. Alright guys, I think that's about it. So this is what happens when the atoms combine. Sometimes they combine and form compounds where they're going to be all together and you can't break them down. Okay, it's always the same elements in proportion. Other times they're going to come together and form mixtures. Unlike compounds, a mixture, you can change the amount of different substances in the mixture and it's still a mixture. Okay, chocolate milk is the easiest one. If I were to make chocolate milk for everyone in the class, some of you guys would like it super chocolatey and others of you guys would like it just a little bit chocolatey. It's chocolate milk, it's just in different proportions. Okay? Alright, I hope you guys have a great night. Don't forget, write a good question, do some good summary statements, and then as always, don't forget that quiz on the back. I will see you guys all tomorrow. Have a great night.